Okay. Hello everyone. Today we will have some uh, review. Hopefully today and next Monday, we will have a review for your final exam preparations. So we will review from chapter 5, 6, 7, and 8. And I have graded your score. Uh, if you want to take your uh, quiz, you can go to my office on Monday or Tuesday. Or if you don't want and you just prefer to know the score, I will put the score on Google Classroom later. Okay, maybe maybe tonight. Okay, and I will also put last year final exam the question. I think I will also put on the Google Classroom so you can have some discussion, study, exercise, and uh, hopefully next Monday we can solve some problem from those questions. Okay. And about our final exam, uh, remember we will have final exam from 8 a.m. This is on January 14th. So next week, okay, next week. Yeah, next week, next Friday, Friday from 8 a.m. Okay, until 10:30. Okay, so the total will be 2.5 hour durations. Okay, the place is on place is on IB. Let me check the place. 60 6011 and 6001. Oh, 6012 and 6021. Okay. So we need to have to split the class into half. I will let you know who goes to the IB 601 and who goes to IB 602. Okay. Okay. Now, perhaps before we are going to solve some questions that I have prepared, uh, let's just review some of the quiz. I think I will start from this question. Okay. So the region bounded by the given curves is rotated about the y equal -1. Find the volume of resulting solid. I think this is number three, right? Okay, in your quiz. So the important thing on this chapter 6 on volume is to differentiate the method. Okay, which method we are going to use. Okay, it is the disk method or the shell method. Okay, if you look on the visuals, the graph itself, we may have um, let's say this is the x squared plus 1, and the other one, let's say, although it's not really proportional to the ratio, let's say we have, and this part is 9 minus x squared, and we have y equal -1 will be there. Okay, and we may have rotations here, right? So this is x, this is y. Okay, and if we are going to look on uh, the area or the region that we are going to rotate, this will be uh, the rectangle that probably will take place. Okay, and so we are going to rotate through the y equal -1 there, here -1, right? So imagine um, we will have a disk. Okay, we will have a disk method. How to know? Because when we rotate, there is nothing wrong in the graph, right? Okay. If you goes to using the, let's say, dy like that, okay, there is something intersect at this point, right? Let's say point B, which means uh, you need to take separations between two area, right? At least, but I think we can just focus on this method. Okay, so we will have to identify the radius. We will have two radius. This is the inner radius, right? And this will be the outer radius, right? So this is the disk method with hole, or we call also washer, right? Washer method. So let me make some notes here. Use washer or a disk with hole. Okay. And before we start to calculate the volume, we may need to find the point here, right? And A and B. So we may find through the uh, equations. So we can have the x is -2 and 2. Okay. Now, since it's symmetry, okay, because of symmetry to due to the symmetry, then our volume we can have twice of the uh, from 0 to and the area will be the outer radius. Okay, the outer radius is from the 9 minus x squared. Okay, 9 minus x squared plus 1. Okay, plus 1 from here, from the y equal -1. So the outer radius will be 10 minus x squared squared. Okay, minus, let me just write pi again to give you a step-by-step process. And the inner radius, this green color here, okay, this is inner and this is outer. Okay, the inner one is the blue curve, x squared plus 1 and then plus 1. Okay, so this plus this. Okay, hope you get the idea. The outer radius, this, okay, plus this, right? So the inner one will be x squared plus 1 plus 1. So let's say 2 plus x squared. Okay, and then we integrate with respect to dx. Okay, now we integrate this. Let me write, let me calculate here. It's 100 minus 20x squared plus x to the power of 4. Okay, and careful when you are doing this, because I think some of you take the expansions in the wrong calculation, so you get the wrong answer. And this one, 4 plus 4x squared plus x power 4. Okay, so we take this. 100 minus 4 is 96. Negative 20, negative 4 is negative 24x squared. And we can have this cancelled nicely. So this will be our integral. Okay, and this will be easily to be integrated as 696x minus 8x cubed from 0 to 2. Okay, so 2 pi 96 multiplied by 2 minus 8, right? Can compute a little bit. This will be 1, 2, 64, 128. 128 multiplied by 2 will be 256 pi. And that's the answer. Okay. Okay, I hope you guys get the correct answer. Okay. But I think most majority, you guys get the correct formula, but the wrong calculations. But I think some of you did not get the correct formula. Okay. I hope you guys get a clear clear process on how to solve this. Okay, let's move to another one. We'll just start with the chapter 6. Okay, and yeah, still volume. Yeah, I took it from somewhere in the website. So you have to find the volume of the solid obtained by rotating about the y-axis, the region between x-axis and y equal cosine x. Okay, and the interval is from 0 to pi over 2. So try to check the results. And if you'd like, you can try maybe using, if you can use shell or even using the disk method, you can check. Okay. I think we can start by drawing if you want to draw. I think since it's a cos sine x, it's not too complicated. Let's say this is 1 pi over 2. So we need to rotate through y-axis. This is x. So this will be the area. Okay. It seems that if we took uh, either way uh, through this dy or or the x, I think both methods works. Okay. You can pick which one you think is better for you. Okay. Now to solve the integral itself, maybe you need to solve by integration by parts. Integration by parts. if we take the dy, okay, if we take the dy, then we will have the disk method. Okay, so if we write here, we'll make it smaller. So first is the disk method. So if you look at the green rectangle dy, then the problem here, we need to take the functions in terms of functions of y. So we need to change this cosine x become cos inverse y, right? At least
Yeah.
this is what we are going to do.
And how?
I think someone need to mute the microphone. And yeah, so if we are going to do this method, going to the cosine inverse y, so we are going to evaluate from 0 to 1 for y-axis, right? So the volume will be integration from 0 to 1 pi, and then the radius is the let's call it. So this will be the radius. Okay. So the radius will be cos inverse y squared dy. Okay. Okay, at least we have the volume. Now how to solve this? We turn again this part here. Let's say this is the x cos inverse y. This is y equal cos x, right? We take the derivative, right? And we do the substitutions. So when we do the substitutions, basically we are going to convert back to the x, but with the different pattern. So when the y is 0, then the x is pi over 2. When y is equal 1, then the x is equal, right? So we are having volume, sorry, volume from pi over 2 to 0. Okay. And we have cos inverse y. This is, we can exchange all this. So pi x. And then we have dy is minus sine x dx. So let me write here sine x dx like that. Oh, sorry, square. Forget the square. And let me write in more clear. Uh, I think I can write the. Oh, I think because it's negative, we can switch the endpoint. We can switch the endpoint, and it's become okay. Now, how to solve this? Now, let's concentrate on this uh, x squared sine x dx. Now, we can have the integration by parts, if you remember, because we have a polynomial and a trigonometry. So better to derive and integrate this, right? Derive the left and integrate the right part. So it becomes, Let me write the whole thing. Integrate. Okay, and take the signs. So we will have pi minus x squared cos x, and then plus 2x cos x, and then plus 2 cos x. I mean to input the value. So we can input the value for pi over 2. This will be 0, right? Pi over 2 is 0. Pi over 2 again, this is 0. All 0, right? So we should have 0 minus. I mean, make different color to distinguish the. Wait, I need to recharge my Apple Pencil. Sorry. Okay, wait a few minutes. A few minutes. Oh, I did some mistake. Sorry, sorry. It's not cos. Sorry. Should be sine. So this should be pi, right? So this should be wrong. Recharge again my Apple Pencil. So okay, I think I can write for a while. Sorry. So pi, and then the 0. Let me take different colors. 0 will be 0, 0, and this will be 2, right? So this will be 2. So this will be equal pi squared minus 2 pi. This is this method. Okay. Give you time to, if you want to take notes. And I think because this method, in our case here, we have the trigonometric functions. When we are dealing with changing the x to y or y to x, sometimes we are having the inverse if we are dealing with the trigonometric function. So sometimes you need to take this into the inverse form. Okay. Okay. The second one, if we try to use the shell, let me write here the shell. If you want to use the shell, then we are going to have this dx, rectangle dx. Okay. Then we will have, this is the height. We need the height, right? And we need also the radius. Radius here. The radius in our case here, this will be just x, okay? Just x, variable x. The height will be the functions, the cos x, right? So the volume, and we are just going to evaluate from 0 to pi over 2 in x interval. So we are going to evaluate 2 pi x cos x. Okay, I think it's more simple because you don't really think to change the y and x. Okay, and you can try to evaluate this x cos x dx. And I think it will be simple to start to differentiate and integrate. This will be 1. This will be sine x. So plus minus plus. So we can have 2 pi x sine x plus cos x from 0 to pi over 2. So 2 pi, pi over 2, this is pi over 2, pi over 2, 0, 0 plus 1. Wait, is there any mistake here? Integrate. Is there any mistake that I make? This is the same as this. It should be the same answer. Is there any mistake I make here? Let me erase this password. Let me check with the original. Just to check. Okay. The x on x. This is from 0 to minus v from 0. This will be pi squared, right? sorry. Should be having all this by, so pi over 2 minus, this will be cos x from pi over 2. Oh, yeah, it's correct. Ah, it's 0 minus 1, so minus. Okay. So it should be 0 minus 1. It's minus. So it should be minus 2 to pi. To pi. So it should be minus 1. So pi squared minus 2 pi. Okay, let me check again this part. It's 2. Okay. Okay, should be the same volume. Okay. Okay, we can move to next example. I think, yeah, we can also try this one. It's similar to your quiz, but different functions, but similar. Okay, similar. Okay, so first question from this problem is, we need to know what this means, right? It means that either cos or sine, they at certain point they can have at uh, the cos is above or sine is above, okay, in the top. Okay, so like example, like this. So sometimes the let me maybe this, if this is the sine, this is the cos. Sometimes the sine is above the cos, or sometimes the cos is above the sine. So this symbol here means that no matter cos or sine is above, we need to calculate the area between those two curves. Okay? So we need to find, and we need to make sure which functions is above the other functions. Okay? So in order to doing so, we are going to first identify the intersection. Okay. No matter how the picture is, since you know how the cosine and sine will interact, and I think they already give um, the square, so it's I believe it will be making the graph easier because they will not have any negative value, right? So they will have not negative value here, right? Okay. So first we take the cos squared x equal 3 sine squared x. And we may look at the sine squared x over cos squared x. Okay. If we look at, because it's all positive, I can do some cross multiplications. So we will have some 1 over 3 like that. So we have sine x cos x is square root of 1 over 3. And we know that in tangent, this will be resulting in x is at least pi over 6. Okay, but pi over 6. And we know that we are just having from 0 to pi over 2. So only in the first quadrant. And because of the uh, all having a square, then all value must be positive. So we can do this calculations. Okay. So we can write down. Let me write the questions one more time. Okay. So we will have uh, from 0 to pi over 6. The first one is cos is going to be above. So cos squared x minus 3 sine squared x. Okay? And then dx. And then plus from pi over 6 to pi over 2. 3 sine squared x minus cos squared x dx. Okay. And then we can solve this. Every time you see any cos squared or sine squared, we are going to have and also this. Okay. Then you will have cos squared x is cos 2x over 2 plus half. Okay. And sine squared x will be half minus cos 2x over 2. Okay. Now we can solve the integral. So the first one, we can take the cos 2x over 2 plus half minus 3 over 2 minus, it become plus, right? Plus sine 3 sine 2x over 2. And the second one, 3/2 minus 3/2 cos 2x. Oh, why I'm writing sign here. Cos. The first one is this, and then minus the cos squared x is cos 2x and minus. Okay, so 4/2, so this is 2 cos 2x minus 1, right? This is 1 minus 2 cos 2x. Right? Okay. Okay, we can take the integrations. This will be minus x plus, or we can write the first one first. 2 sine 2x over 2, so 2 will be cancelled. So this will be sine 2x minus x from 0 to pi over 6 plus, okay, plus x minus sine 2x. Okay, this is from pi over 6 to pi over 2. Okay. This will be pi over 3, right? 5 sine pi over 3 is half of square root of 3 minus pi over 6, and the rest will be a 0, and then plus pi over 2 sine pi 0, so 0, and then minus pi over 6. To make it more clear. Okay. So this will be half square root of 3 minus pi over 3 plus pi over 2. What will be here? It's positive, so it should be equal square root of 3 plus pi over 6. And this will be the answer. Okay. I think that is for mostly chapter 6. Chapter 6. I will also give you the. You can check the recording on the other class as well. I have also reviewed some materials on different materials from our class today, so we can have more example and more review, and you can have more exercise. Okay, I think we can move to the other question. Okay, maybe let me wait a few minutes, maybe 1 minute for you to take notes. Okay, I think we can move to next session. I think I can give you example on the surface area. Yeah, I think I forgot to mention last time. So example on the surface area. Let me write the question first. Surface area of the figure obtained by rotating y equal x cubed on the interval from 0 to 1 on x-axis about x-axis is so you have the curve x cubed, you have the interval from 0 to 1 in x, and it's rotated about x-axis. It's rotated about x-axis. If you would like to try, you can try. This is just take the curve interval into the formulations for the surface area. Let me give you a few minutes to check and try. There's interesting idea on the surface area and volume, because we have learned the improper integral, right? We can have the interval from, let's say, from 0 to, or from 1 to infinity, right? If you remember the 1 over x or 1 over x squared, right? If you can rotate the curve of 1 over x, rotate through x-axis, and you have the interval is in the infinite interval, there is some interesting idea behind the surface area, that when you calculate the volume and compare with the surface area, sometimes there is some different answer. So you may have the surface area is finite and the volume is infinite. And sometimes you will have the volume is finite and the surface area is infinite. It's interesting. It's an interesting fact. There is one example in your chapter 8, I think, or chapter 7. I forgot. I think yeah, chapter 8 or 7. Uh, I think chapter 8. So we calculate the surface area of 1 over x, I think. 1 over x. Yeah, 1 over x. It's called the Gabriel Horn examples. But later we can if we have time we can show some of the examples. Okay, now this part here. Okay, well, you don't really need to draw because it's just an x cube. But if you want to draw and to know how the graph will be, um, this is how it looks like, at least, right? At least like that, from, let's say, from 0 to 1. It's rotated through about the x-axis. Okay, like that. Okay, so idea here is, let's say this is 1, 0. So we will have, this will be our radius, right? This will be our radius, which is the y, or function of x, right? This is function of x. Then we can, first we can write down uh, the functions is x cubed, and we may need the dy over dx, right? Because of the arc length. Or let me write the formulations first. The formulations. It needs the dl. Okay. So the surface is 2 pi. This is y. Let's write dl. Like that. If we try to make it into x, variable x, okay, we can write this and write the dl as an arc length. Okay, dl is an arc length. Okay, dl is an arc. So arc length in terms of dx means that we have the square root 1 plus, this is dy over dx. Okay, or let me write to make you remember. So 1 plus dy over dx squared dx. Okay, so we can write that. So dy over dx is 3x squared and squared, okay, and dx. So we have some a little bit calculation here. That is, this will be, turns out to be 9x with power of 4 dx. Now to solve this and to solve like many integrations in the applications, we may need some techniques, either substitutions, trigonometric, or even integration by parts. But I think mostly if you see the square root, usually we are going to substitute either just a regular substitutions or with the integrations with the trigonometric functions. If we look here, the first part here is having cube, power of 3. Inside is power of 4. So I think it is, we can see it clearly that we can have we may we may have the x or as our u if we want, okay? Because if we check the du, this will be 4x cubed dx. Okay? Then the x will be 1 over 4x cubed du. then this will be resulting in when x is 0, u is 0. When x is 1, u is also 1. So there's no problem there. So we are still having 0, 1. X cubed 1 over 4. I will write it like that. And this will be resulting in 1 plus 9u du. Oh, I think we can substitute the whole thing here, right? But I think we can also do substitution again here if you want the double substitution. But let me try the whole thing first to get a direct answer. But if you do this, then this will be the resulted in different. So this will be resulted in 1 to 10 x cubed divided by 3 36, and this will be square root of u du. Yeah, I think better doing this one. This is u half, so you will have u 3 over 2, 2 over 3. So this will be 2 over 3. Oh, let me take 2 over 3 outside. Then this will be, I think better. 10 3 over 2 minus 1, right? So this will be pi over 27. Then yeah, I think better to choose the substitution directly. Okay. And that will be the answer. And I hope you guys, if we have like the questions with combinations chapter with combine problems in one question. Um, First, you need to identify what is the question, what is the goal of the question, what to find, and which method you are going to use. Okay, we have several techniques of integral, right? And we have several applications like arc length, surface area, the volumes. It's all I think the applications part. Let me give you a few minutes to take notes if you would like. So let me just erase this part. Okay, this we don't need this. Okay, if you have any question, you can write in the chat box. Okay. Let me back to QR code. Okay, for those of you who haven't scanned, you can scan QR code. By the way, next Monday, the class is actually optional. It's not really. But if you want to review, I will give some review, but maybe not like in a full class, but maybe just a 1.5 hour, and maybe focusing on more on the uh, last year final exam, maybe several questions. Okay, and then please remember, okay, next week final exam morning, okay, in the morning, January 14th. The place will be in IB, okay, International Buildings, 6th floor, 601 and 602. I will let you know who will be at the 6012 or 6021. Okay. So we will split the class into two, okay, two classroom. Okay, we can continue. Continue. Okay, this one. Now this one. Okay, we have um, an exponent, but in a terms of a fraction, a big fractions. Yeah, it's a little bit uh, complicated, but I think we can solve. Let me give you maybe a couple minutes to try to think. Um, okay, any idea how to solve this? Okay, the first clue, how to solve this is you can consider some substitutions. Okay, let's say we can substitute the e to the x. Okay, let's substitute this with the let's say t. Okay, if we try to find the derivative, or if we try to write down x in terms of L and T, okay, because we are going to have d dx is 1 over t dt. So we are going to remove all the e with power of x, also changing the dx into the dt. And we are going to have some substitutions. Then the formulations will be, or the integral will be 1. This will be t squared plus t plus 1. And the dx will be having another dt over t. Okay? Or we can write this as t. Okay. Okay. At least we are removing the e, right? The exponent. But the problem now arises since we know, or we can see clearly from this quadratic functions. I think we cannot factorize this, right? We cannot factorize. So what do we do now? We cannot factorize this, but let's say we are going to have a partial fractions. This is the first and the second equations. So we can write down, or maybe write down some random functions. G, this is equal this, and we may find the partial fractions first. A, B, and C is a constant. Okay? So we can find from A this is equal 1. Since I think we don't really need to solve the system of equations, we can input some t, maybe t is 0, then we have a plus b is 0 and plus c also 0. I think this is a is 1. Okay, so from when t is 0, a is 1. And I think we can just write this. Plus, or since it's 1, so we can write directly t squared plus t plus 1 plus bt squared plus ct. We can write down that t squared is b plus 1 plus t c plus 1, okay, and then plus 1 is equal 1. So b plus 1 should be 0. C plus 1 should be 0. Okay, now c plus 1 b plus 1 d squared. Let me check first. C plus 1. Okay. bt squared ct. And from here, if we have the a, uh, bt. Okay, let me check with the other one. So a t squared at plus a. Okay, just checking here. So a is 1, a is 1, a plus b, a plus c is 0. So b minus c is 0. So b is equals c. Since b is equal c, 1 plus b is 0. So b is -1 and c is also -1. Okay, just checking to make sure. Yeah, b is -1, c is, yeah, this is true. Okay, this is true. Okay, so we are going to have uh, integral 1 over t squared plus t plus 1. This is 1 over t dt plus negative t negative 1 t squared plus t plus 1 dt. Okay. Now we still have um, some integration here. Okay, I think we can move a little bit to the right for this partial fraction. Maybe moving here. Okay, well, now what we can do in our case here. It's a little bit tricky. It's a little bit tricky. So I want to separate this, okay? And if we look this part here, if we imagine we are going to use substitutions and we want to cancel the top equations, we can imagine that if, okay, let's say this is, let's say gx is, or gt, or maybe not g, maybe h. If we try to find the derivative, this should be having 2t plus 1, right? 2t plus 1. but we still have, in our case, is negative t minus 1. So we are going to force the equations to be 2t plus 1. So we need to multiply or maybe separate the equations. Okay. So what we are going to do is we write first 2t plus 1. Sorry, 2t plus 1 in terms of this integral. Okay. And 2t to becomes the uh, negative, we need to multiply with negative half, right? If we multiply this, this will be negative t and negative half. So we have a negative half, not negative 1. So we need to negative half here. Okay. I hope you get the idea. So the whole thing, okay, the integrations will be, this will be, let me just write plus and then this is multiplied negative half, and the integrations negative t, negative 1, negative half. Sorry, not negative t. This is 2t plus 1 and a negative half. Okay. Now I will separate this part. Okay, so I will separate this into separate integral. Okay, got the idea? You got the idea? So whenever you see any fractions that you think you can substitute and you need to somehow uh, rewrite the form or exchange the form, you can force them into using these substitutions. Okay, you can plus minus with any number, you know that uh, when you, but remember when you are doing this, remember that our true or our original equation is this. Okay? What we are doing here is just some multiplications, and when we are, let's say we try to multiply this and then minus with the half here, minus half, it turns back to our original equation. So this is eligible, and this is eligible, and we can somehow manipulate our integral. Okay? We force to make some substitutions. Okay. Okay, we still done, not really done. Okay. uh, I think we can see that this will be ln, right? Ln t, and this will be minus half, and this will be if we let the u is t squared plus t plus 1, du is 2t plus 1, right? So it's clearly going to have direct substitutions, and we will have 1 over u. So this will be, turns out to be ln. We're still not done yet. We still have this. The last part here is also a little bit tricky. A little bit tricky, this part. So if I write this, the last part as negative half, and then this will be dt over t squared plus t plus 1. Okay. Okay, can we think any functions that we can integrate with this t squared plus t plus 1? Okay, remember, if we have a tangent inverse x, we differentiate, this will be 1 over x squared plus 1, right? If we have this will be 1 x squared over 4, right, plus 1, and we need to multiply with half. Or we can write down this in terms of um, 4 or 2 s squared plus 4, right? So if we can take this form into this x squared plus 1, can we do that? If we take this into this form, let's say we have t plus half, okay, in the square. This will be turns out to be plus t, right, and plus 1 over 4, right? To be to become 1, we can plus 3 over 4. Okay. Now let me move this to okay. Now let's say we have um, this we can write as 2t plus 1 over 2, right? So we can write this as in terms of a tangent inverse. Let me write tangent inverse of 2t plus 1. We have uh, 3 over 4. Okay, 3 over 4. So we need to square root of 3 over 4. So over 3 like that. Okay. Because we have this 3 over 4. And also, we need to also multiply this with the 2 over square root of 3. So we will have negative 1 square root of 3 tangent inverse. This is actually from, let me write the full uh, okay, we got this. And we may write down uh, the answer here, but it's not yet finished. We still need to consider the x. This is t, right? Um, don't forget to plus c. Okay, since t is, remember that t is e with power x, so we will have this is x, right? This is negative half ln e2x plus ex plus 1 negative. This is 2 e with power of x plus 1 square root of 3 plus c. Okay, now this is the answer. Okay, it's really complicated, I think. Yeah, but somehow we can solve it. And do you think it's difficult, right? Yeah, I think this is quite difficult. So I think it's a good exercise. Good exercise. Because you have many techniques in one problem. You have a first substitutions, partial fractions, doing substitutions again, and then the tangent inverse at the end. If you feel confused, this if you have 1 over x squared plus a squared dx integral, this will be 1 over a tangent inverse x over a. So this x over a is I multiply directly. Let me give you 1 minute to take notes from here. If you have any questions, you can write on the chat box. Later, I will give you all the notes. Okay, yeah, I will give you all the notes. You can study from the notes also. Okay, I think we can move on. Okay. Well, I think we can move to maybe one or two questions. Maybe one more questions. Maybe last question. Last question. Okay. Okay. Uh, yeah. Last question. I think last question. Integral from 0 to 1 of sine inverse x, squared of x. Can uh, and try to solve. Do you get the result? Do you get the result? You can write down in the chat box if you find. Yeah, we need to take some time to substitute with, I think, to remove the inverse. If you think the inverse is um, making difficult, we can take some substitutions first to substitute the inverse. Or even you can substitute the square root x to remove the square root. But I think that way still a little bit complicated, but that can be done also. Okay, okay, first we can set maybe u, okay, or y, or any variable you want. Maybe just u, sine inverse square root of x. Okay, then we will have square root of x is sine u, right? Or even in these terms, we can have x is sine squared of u, right? And now we can have the dx is, it's become 2 sine u cos u du. Or remember that we can also change to double angle for sine 2u du. Okay? Since it's substitute, we need also substitute the endpoint. X is 0, u is also 0, x is 1, right? So u will be, it's pi over 2, right? So we can write down that this is equal to from 0 to pi over 2 u dx is sine 2u du. Okay, this is the first step. And the next step will be taking this integration and I think this is a quite simple integration in the integration by parts. We can take this don't forget to divide by 2. So we will have so minus pi over 2 minus 1 divided by 2, or maybe let me write in terms of, say, half, negative half outside. So pi over 2 cos pi is negative 1, and this will be negative 0, right? And plus this is 0, should be pi over 4, right? Okay. Uh, if you change this, uh, let's say you try to substitute the square of x, this can be done. Okay, this can be done as well. We can substitute with this 2u du, so we can have integrations sine inverse u and then 2u du. Still it's 0 1 because there's nothing changed in the endpoint from here. Okay, but you can still do some integration by parts if you want from here, but it's a little bit more complicated than the this one. The results will be the same, pi over 4. Okay. So I think I will end up until here. Okay. If there's no questions, is there any question? I will upload later the notes, also the final exam from last year, so you can have more discussion. Okay? Okay, if there's no questions, then we will end our lecture up until here.